Question 16. How can a Fieldbus system be implemented in an existing Hart system? Answer. Hart and FF have one great feature in common. They both use device descriptions (DDs). This makes it possible to mix Hart and FF in one system and get equivalent capabilities for device configuration, diagnostics and instrument management. Hardware for a mixed system needs some care. Either a host must offer both types of I/O system, or the host can use only FF, with a Hart to FF gateway to connect to the existing Hart devices. But be careful of the speed difference. In some applications, Hart communication is not fast enough to use for the control variables, especially if multi-drop Hart is used. A gateway may, therefore, have to include analog I/O with conversion to digital form for the Fieldbus connection. In addition, it is not yet clear, at least to me, how a Hart device should be disguised as an FF device by translating its data structures, preferably based on its Hart DD. As far as I know, no Hart to FF gateway yet exists. Question 17. How is scan time defined in a Fieldbus system? Answer. Communication to and between input and output devices in an FF bus is controlled millisecond by millisecond by the LAS link active scheduler. The sequence of communication activities which the LAS manages is set up by the system engineer during design or commissioning. A typical configuration tool will allow you to set up a cycle time for each control loop, whether it resides in the host or in the field devices or partly in each, and will automatically arrange the required communication paths and schedules. Because of the way the LAS works, all cycle times on one bus segment must be fitted into a basic macro cycle. Probably, in most cases, this will also be the overall scan cycle time for control loops on that segment. Question 18. How is speed affected when all instruments in a segment start talking to each other? Answer. For scheduled traffic, including any used for control purposes, the timing is pre-configured and always occurs as expected, under the control of the LAS. This is completely unaffected by any unscheduled traffic. In fact, instruments don't just start talking. What happens is that the LAS gives each device a chance to talk in turn during the time in each cycle allocated for unscheduled messages. If there isn't enough time before the next scheduled message, they have to wait until later. Question 19. When are scheduled and unscheduled communications used? Answer. Scheduled communications are repeated on a regular pre-configured cycle and include those messages carrying measurements or outputs used for control purposes. Unscheduled communications are fitted into idle times in the scheduled message cycle and are used for almost everything else. Operator display updates, tuning parameter and mode changes, process alarms, trend report, configuration changes, diagnostics, time distribution. Unscheduled messages can be prioritized. For example, alarms can be dealt with urgently. Question 20. What are the points to take care of when placing instruments in a particular H1 bus segment? Answer. Geographical layout, impact of loss of the segment, power consumption if bus powered. Question 21. Where is the physical location of the LAS link active scheduler? Answer. This is a system designer's and device manufacturer's choice. If there is a host DIS, the LAS will usually be in the Fieldbus interface card. If not, it can be in a field device, but only link master devices offer this capability. Question 22. How can MCC status be accessed on a Fieldbus system? Answer. Any field device functionality you can imagine can be implemented in a Fieldbus device. Access to any particular item or items of data is defined in the device description (DD), which a host should use to interrogate the device and interpret the response. Some common device types have profiles. Using a standard DD to reduce the work involved in development and to achieve a degree of interchangeability, but I don't believe an MCC profile has yet been published. Question 23. How do you calibrate a Fieldbus instrument? Answer. This is really no different to any other smart transmitter, except that now you don't have to worry about the 4 to 20 mA analog signal. You just need to read out the measurement over the bus with a suitable host device. You need a source of the process variable, pressure, temperature, or ohms or millivolt, CH, or whatever. Typically, when you connect a known process value to the sensor, you can send a special message to the device, including the value you read and what it should be. The field device will then adjust a stored parameter to make it so. Two values, near the ends of the instrument's working range, are usually enough, though some devices may use a more complex multi-point calibration in the factory to adjust linearity corrections, or even a temperature cycle to adjust temperature correction. Automatic calibrators will step through this process with only minimal user involvement. Question 24. What is the length of the Fieldbus message? Is it different for discrete and continuous variables? Answer. The total message length can vary from 11 to 276 bytes, called octets in the Fieldbus world, depending on the message type and data content. There are no extra start and stop bits, so at 31.25 kilobits per second, each byte takes 256 microseconds. The whole message could therefore take anything from about 3 to 70 milliseconds. Reading a single variable, whether it is discrete or continuous, would be near the shorter end of this range. For efficiency, several variables can often be collected into a single message. Question 25. Is fuzzy logic control introduced as a standard function block in Fieldbus? Answer. Not as far as I know, but proprietary forms of this function should be available from major manufacturers. Question 26. How can cascade, ratio, split range, feed forward and override control be achieved through Fieldbus? Answer. The first set of standard FF function blocks include PID with remote setpoint input and feed forward input, ratio, bias/gain for split range output, and signal selector for override control. Question 27. Can HTG, hydrostatic tank gauging, be achieved using a single Fieldbus instrument? If so, how? Answer. It should be possible. Multivariable transmitters are well supported by the ISA and FF protocols. A Fieldbus HTG instrument might connect directly to multiple sensors, pressure, temperature, or might perhaps use a local multi-drop Hart bus to connect to standard Hart transmitters. These could also be powered from the Fieldbus through an embedded DC to DC converter in the HTG device. Question 28. How can multiple variables be measured using a single Fieldbus instrument? Answer. No problem. A device can have as many sensors as the designer wishes, and further derived variables can be calculated from these if desired. Each measured or derived variable is represented by its own analog input block and is thus available to read over the Fieldbus. In particular cases, it may be useful to combine several measurements into a single data array for more efficient messages. Question 29. Can a control block, for example PID, be inserted in a transmitter instead of in a control valve? If so, how will performance be affected? Answer. Yes, it certainly can. There isn't much difference in performance. There is one extra message per cycle to balance the PID output value to any limits imposed by the analog output block in the valve positioner to avoid integral wind-up. In a cascade control application, it is quite likely that the primary PID will be located in the transmitter for the primary variable. Should an IP converter be built into the Fieldbus compatible control valve? If not, how would an IP from a different vendor be tested as interoperable? There really is no IP converter anymore. I would expect a digital to P function to be built into the Fieldbus valve controller. As long as the valve itself remains pressure actuated, the controller might or might not be physically mounted with the valve itself. Question 30. What does the control hierarchy for a Fieldbus system look like with control in the field? Answer. You can put the regulatory control loops in the field if you wish, with advantages of performance and reliability. Complex control functions will stay in the Ds. Supervisory functions, data analysis and links to management systems stay where they are now, but perhaps take extra data directly from field devices by pass-through via the Ds. The right level to put any function is the lowest at which all the necessary information is available.